right, this is OXDF looking at day 25, Sea Cucumber, the last day of the 2021 Advent of Code. Basically, I'm going to be given, let's skip ahead here, this grid here that is full of sea cucumbers. And there's two kinds of sea cucumbers. The one that looks like a angle bracket moves east, and the one that has a V moves south, and everything else is empty. And basically what's going to happen is all the east-facing ones move east if they can. So like this one actually can't because there's a cucumber there, and then this one can, so it moves here, and then this becomes empty. And they all have to try to move at the same time. So even though the fact this one's clearing out the space doesn't make this one able to move in. Now the next time he'll be able to move in, but okay. And same thing. So everyone moves east, and then everyone who's south moving moves south, and that's a step. So they kind of go through all that here. So like in this case here, what's the step? This east one is going to move out of the way, and then the south one can move south. But then when you run in something like this east one's going to try to move and fail, and then the south one's going to move, and then the next time that east one would succeed in moving. Although actually it would, yeah, it would. Okay. So anyway, we get some initial state, and after a bunch of steps, and apparently what we're going to find is at some point every sea cucumber is going to be jammed up against another sea cucumber and not be able to move. And so basically they're asking for how many steps happen when they've all stopped moving. So what's the first step in which no sea cucumbers move? They usually go easy on us on day 25, and I think they have here. And typically there's only one challenge, so we'll check that out. Let's jump over here and get started. I've got my example down here on the bottom, and some stub code here. And I'm just going to actually, let's see. We can do a little bit of editing here on how we read it to get it slightly differently. And we'll make this a list of line.strip. Is that right? Oh, we need that for line and that. And so this is going to give us, and what the list is going to do, if you have that, is Python 3. If I have something that looks like this, like that, if I say that's x equals that, if I do x dot, if I do list of x, it's going to give me each character as a item in a list. And the reason this is important is what I can't do now is I can't say x of 6 is equal to like that. Because a string object does not support assignment. But if I then come up here and make y equal list of x, so y is that. If I now say, y0 equals dot, now y looks like that. And that's what I want. So I want to be able to assign. So I'm going to read every line, and then for each line, I'm going to strip it, remove the new line from the end, and then turn it into a list, which is what I'm looking for. Cool. Okay, so we'll use, since we're going to need this over and over again, we'll use big R as our length of number of rows, and we'll use big C as the length of the number of columns. So that'd be the length of grid 0. I'm assuming that the length of each individual row is the same. And so then we'll just do t equals 0 to count our steps, while true. And so the next thing we need to do is because we're moving all at once, we want to make a copy of the thing, and that we'll move in a copy, and then we will update the original. So we'll do something like next grid equals. Now it's really tempting here to say grid, but there's a challenge with that, and I'll come down here again. I'll show this. So I have y here, right? If I say z equals y, make a copy of it. So there's z, there's y, they look the same. If I say z of 1 is equal to, it doesn't matter, 0. So z, there's my 0 in the first instance. But if I do y, it also has the 0. And that's because when we do this assignment, y is like a pointer to this list object. And so I'm making z a pointer to the same list object. So if I change either of them, they both change. And that's not what I want here. Now, a simple way to get around this is, if I say z equals x for x in y, like this, and I have z and y like this, If I say z sub 0 equals 1, and I now run y stays the same, z has changed. And so basically, when I do a list comprehension, it ends up creating a new object. And so that works really nicely. Now I actually need to do two objects, or the other way, sorry, the other way you can do this, I should say, because I'll use this as well. So let's just say z equals y like that. And when you do this, this is basically saying y, all the items in y. But it actually creates a new list there. So if I do this, and then I do, so if I do z and y, they're the same. If I do z sub 0 equals 9, z is updated, but y has not. So back here, what we're going to do is we're going to use both those together because we actually have nested, grid is an array, is a list of lists, and we need each list to create a new one. So we'll do row for a row in grid, and then instead of just copying the row object, we're going to make it like that, and that gives us a new row object. And so it'll give us a brand new grid that looks exactly the same. Okay, so we can do for r in range r, for c in range c, if grid sub r sub c equals, and that we're going to move the east facing one. So if it's that, and grid sub r sub c plus 1, I'm going to fix, that's a little bit broken, we'll have to fix that in a second, is equal to a dot, so it's empty. Then we'll say next grid sub r sub c plus 1 equals that. Probably be consistent with my quote, so that doesn't really matter. And next grid sub r sub c is now an empty space. So it's like that. And that's it. That's going to move all of our east ones, right? Now there's one challenge here, and they say in the challenge that due to this, I don't think I mentioned this, but we should go back and talk to it. Let's see, where was it? After a single step, blah blah blah, for every step. Somewhere in here. Okay, due to strong water currents, kind of ridiculous, the ones that move off the right edge appear on the left, and the ones that move off the bottom appear on the top. Kind of weird, but sure. Okay. So all we need to do here, though, is let's say our grid was 10 wide, right? And so they went 0 through 9. Well, what we want to do is really check and see if we're trying to check 10, what we're really doing is checking 0. So what we need to do here is we're going to just do the modular. So we'll do c plus 1 mod c. And that'll get it, and that'll get us back around the grid if we need it. Mod c, like that. And I think that looks pretty good. So now we've moved all the east ones. Now we need to move all the south ones. And so what we actually need to do is create another, we can create another next grid, or we could try to update it, but I actually want to keep, we could update grid to next grid and then start a new next grid. But the problem is I actually need to make sure I'm tracking when nobody changes. And so I need to keep some idea of what grid originally was for the beginning of this loop. So I'm just going to create next grid 2 equals and do a very similar thing here. Row for row in next grid. And so I'll do the same thing. In fact, I can just see 5 yank paste for R and C. For R and C, if the thing is equal to a moving down cucumber, and then I need to do the same thing over here this time. So R plus 1 mod R, and this will just become C because the column isn't changing. And now we come down here and do the same thing. So we'll just do plus 1 mod R and C. And I think that looks pretty good. Let's see. So now we can say T plus equals 1, because our number of steps has gone up. And then if grid equals next grid 2, break. And otherwise, we're going to say grid is equal to next grid 2. And I think that's pretty good. So we get to the bottom here, and we will just print part 1 and we will print T. Seems reasonable. Let's give it a try. Python 3, day 25. It's been a while since I got one right on the first try. 5 does not seem right. So let's see. Oh, I see an issue here. So we set up our next grid too. So for this one, we need to be searching in next grid to see if there's space, and then upgrading next grid 2. Let's try that. I think. I don't like the way that's spinning up so loudly. That seems wrong. All right, let's see. Oh man. Oh, this is the downside of copying and pasting. I'm turning all of the south ones into east-west ones, and that ran very quickly. 58. Okay, so we can do puzzle input and see if we get. It's gonna take a minute longer, but not that much longer. Let's see. Is that right? Awesome. Okay. Continue to part 2. Part 2. The console lights up. The keys are directly into the submarine. You landed right on them. You moved to the airlock. You need to get them in. Check the clock. It is Christmas. There's no way you can get them back to the surface in time. Just as you lose hope, you notice a button on the sleigh keys. Remote start. You can start the sleigh from the bottom of the ocean. You just need somebody to boost the signal so it actually reaches the sleigh. Good thing the submarine has an experimental antenna. You just need 50 stars to boost it, though. The experiment lights up, and it says you've got access to 1 star, so you need 49 more. We will click remote start, and boom, we got our 50th star. They always make the last star kind of a freebie for Christmas Day, which is nice of them. So awesome. That's Advent of Code this year. Let's see, is there anything worth reviewing here other than don't make silly typos? Pretty simple. The tricks here would be making sure you keep track of your original state at the start of the loop, and then after 2 moves instead of just 1. Another simple way we could have done that is set a variable up here to like complete or same equals false or same equals true, and then in here under each of the ifs, if any of them or like done equals false, and then if either of these ifs have an issue, you could set it to true, and then you could just check that instead of checking if this comparison here. That would have worked too. But otherwise, pretty straightforward challenge for the last day. Thanks for sticking around with me till the end. This is now has a video up for everyone except for day 23. I'm gonna have to look at my solution on that one and see if I can figure out. Right now, the code I have to solve it takes like 20 minutes, and it's unfeasible. It's not good. And I gotta figure out why it's taking so long. So before I post anything. So, but anyway, thanks for sticking with me till the end, and I'll talk to you next time.